Hello everyone. In today's session, we are just going to learn about the regression analysis, which falls under your unit 3. So regression is nothing but it's a statistical process for estimating a relationship between dependent variables. Sometimes it is also called as an outcomes or response. If it is one or more independent variable, it's often called as predictors, covariates, or explanatory variable or features. Okay, regression is nothing but estimation of mathematical relationship between the dependent variables. So based on this regression, we'll be finding the equations of line, how the dependent variable are related using equation of a line. So that is called as a regression line. Estimating the dependency by means of an equation is called as a regression line. And we have two types of regression lines, that is regression line y on x and x on y. First, let us learn about a regression equation y on x, which is given by y is equal to a plus bx, where this x is an independent variable and y is the dependent variable which depends on your x, right? And a is called an intercept and b is a slope correspondingly. And the b, the regression coefficient y on x will be denoted by dyx. Okay, and usually when we are just going for the regression line, we will be using with the parameters like mean and variance of standard deviation. So the particular formula for finding here regression equation y on x is y minus y bar is equal to r into sigma y upon sigma x, x minus x bar. If it is y on x, here y will be on the numerator, sigma y will be on the numerator, and y is on your right side, where x bar and y bar are the mean of x and y, and here r is equal to sigma y sigma x will be the regression coefficient, that is the byx. So that is given here. So the regression coefficient is byx. It is the r sigma y by sigma x, and y of x, it is also denoted as r sigma y by sigma x. It is called the regression coefficient of y on x. So this is here regression equation of y on x. So similarly, we can go for regression equation on x on y. We'll be writing it like x is equal to a plus by, and where x is a dependent variable on your y, which is an independent variable, and here a as usual intercept and b is slope. The regression coefficient x on y will be denoted by bxy, whereas regression coefficient on y on x is defined as byx, which is, if it is byx, it is r times of the sigma y upon, which is r times of sigma y upon sigma x. Okay. So again, in terms of mean and standard deviation, the formula to calculate the regression equation of x on y is x minus x bar is equal to, as I said, if it is y here, the numerator will be y. If it is x here, it is r sigma x by sigma y, y minus y bar. So this entire, this is nothing but here regression coefficient dx. So that is specified here. So the replacement of the formula is this. So regression equation of x on y is this thing. If it is y on x, it is y minus y bar, and the regression coefficient dyx, x minus x bar. Right? Hope you are clear with the formula of regression equation of x on y and y on x. We have few properties for regression based on correlation also. So let me go for it. So properties, like if all your the regression coefficient x on y on x, and the correlations are positive, that is if byx or dxy, or all will be of same positive or all will be negative. We cannot have the terms like one regression is positive and other regression is negative, and correlation is positive but regressions are negatives. The mismatch, the combination of both will not exist. If one is positive, the rest two is also positive. Similarly, if one is negative, the rest two coefficients also negative. Okay, so that's what it is never possible that one regression is positive and other one is negative, vice versa. Okay. So, and also one more thing, the regression coefficients cannot be greater than 1 because we have the property like correlation coefficient is nothing but plus or minus of square root of bxy into byx, because we know the correlation coefficient is maximum we have 1, right? So, if your regression coefficient x on y and y on x are both are positive, then your correlation coefficient both are positive, and both are negative, then they are going to be negative. And the regression lines become identical when your correlation coefficient is equal to plus or minus 2, and the angle between them are 0 degree because they are identical, right? And if r is equal to 0, then these lines are perpendicular to each other. So the angle between them, that the regression equation, the equation of regression lines will be like 90-degree making. Okay. So these are the major properties of your regression lines, and a few more we have here. So regression lines will intersect at the mean points, x bar and y bar. And angle between the regression line is given by the formula tan theta is equal to 1 minus r square by r, where r here, this is a correlation coefficient. Sigma x, sigma y, and sigma x square plus sigma y square. You know, your sigma x and sigma y are standard deviation of x and y, and sigma x square and sigma y square are variance of x and y. And suppose if r is equal to 0, if the correlation coefficient is 0 in the sense that the correlation, there is no relations, like, okay, so then tan theta is equal to infinity, that 0, that theta will be 90 degree. So when r is equal to 0, the two regression lines are perpendicular to each other, right? So when if r is equal to plus or minus 1, so this is actually the identical lines. If r is equal to 0, they are perpendicular to each other. If r is equal to plus or minus 1, then the lines are identical to each other. So the tan theta is equal to 0, so theta will be 0 or pi. So the regression lines coincide. Okay, so these are the properties of your regression lines. So based on this introduction, we'll just go and look into the problem, how to proceed it. Okay. So the first problem, in a partially destroyed laboratory record of an analysis of correlation data, the following results only legible. Like these are only the available data. So variance of x is equal to 9 and the regression equation are two regression equations given. Based on this data, we are supposed to find what is the mean value of x and y and the correlation coefficient between x and y and the standard deviation of y. So we are supposed to find x bar, y bar, and we are supposed to find correlation coefficient r of x comma y, and also we are supposed to find the sigma y, where the sigma x is already given. Okay, so first step we have to find the correlation, that is a mean variance, sorry, mean of here given data, right? Mean value of x and y. So to calculate the mean value of x and y, the equation of regression lines has to be considered, because the equation just previously we have learned it, right? The regression line intersects at the mean point. So we'll assume that the regression lines meets the mean point. So these two, the regression lines, are passing through the mean points. So if they are passing through the mean points, what happens? It satisfies these two equations. So the equation 1 will be turning as x, 8x minus 10y as 8x bar minus 10y bar is equal to minus 66, and 40x bar minus 18y bar is equal to 14. So now to find x bar and y bar, we'll solve these two equations. Once we solving, we'll be getting the mean as 13 and 17. So x bar is equal to 13 and y bar is equal to 17. Right? So now we have completed the mean value of your x and y. So the next I have to find the correlation coefficient of x and y. So to find the correlation coefficient of y, I'll go with the logic of your regression coefficient, because we know the logic of correlation coefficient is square root of byx into bxy. So for that I have to find byx and bxy. So let me consider one of your equation, 8x minus 10y is equal to minus 66. So from this, either you take it this as an equation of x on y, x on y, or y on x. I'll say you why I'm just taking this as an equation of y on x, another one as x on y later. Okay. So I'm considering this equation on y on x. So if it is y on x, I have to make it this form. It is y is equal to a plus bx, right? So where this b is here, regression coefficient. So just make the adjustments like writing y is equal to the other side, take 10 to the other side, so I'll get this. So the coefficient of your x is going to be a regression coefficient of y on x. Similarly, considering your next equation as x on y, so x is equal to, we'll get it 0.45y plus 5.35, where this coefficient of y is going to be the regression coefficient of x on y. Okay, once I computed this bxy and byx, it is very easy to go for your correlation coefficient, that is both are positive, so it's a correlation going to be positive. So square root of byx into bxy, so which is 0.6. So the second problem is over. So the third one is we have to compute here sigma, the value of, so we have to compute, yeah, we have to compute the standard deviation of y. So before moving into that, let me answer you why I have chosen the equation 8x minus 10y as your equation of y on x, and other one as x on y. Because if I choose 8x minus 10y plus 66 as your x on y, I'll be getting my correlation greater than 1, because the correlation value lies between minus 1 to 1. So it cannot be greater than 1. So if I'm just assuming, for example, I'll state it here. So if I'm just assuming this 8x minus 10y is equal to 6 as here equation of x on y, I'll get this as my regression coefficient of x on y. And if the other one, if I'm just choosing that as your y on x, I'll get the coefficient b by x this thing. So the correlation coefficient will be like plus or minus 2.777. So which is not possible, because my correlation will be lying between minus 1 to 1. So the way what we choose already, the same byx is equal to 8 by 10 and bxy is 18 by 40, it is 0.68. So when I'm just going with the same scenario, I'm getting the value of r which is less than or equal to plus or minus 1, which is the bound of your correlation coefficient, right? So that's the reason we'll be choosing it, because initially we'll be choosing that assumption as one is b of y of x and b x of y. So when you're just computing your r, you should be, if you're getting greater than 1, then you have to change your assumption, what you made as x on y or y on x as vice versa, to get the correct answer. So this problem, the correlation is 0.6. And the third question is you have to find the standard deviation. So I'll use this one. Either I can use by on x or x on y, because both have the formula of finding your sigma y, right? So if I'm just taking yx is equal to sigma y sigma x, I know what the value of this one from the previous slide. So which is equal to this thing. So on simplification, I'll substitute. I know already what is your sigma x given in the question. It is sigma, the variance is given as 9. So which implies your sigma x is equal to 3. So substitute all the terminologies and finally find what is your sigma y. It's going to be 4. So in this problem, they have asked us to find your mean value of x and y, so which we completed because the regression lines passes through the mean value. And the next one, they are asked to find your correlation coefficient between the given value x and y. So we used both the regression lines and we computed the correlation coefficient. And finally, they are asking us to find the standard deviation of y, which is also done. Okay, hope I think I can understand this very clear. So let me move to the next problem, where the joint PDF of two-dimensional random variable is given by a function f of x comma y is equal to 1 by 3 x plus y, and where x varies from 0 to 1, y varies from 0 to 2. So here we are supposed to find the correlation coefficient equation of two lines of regression. So now no other data is given. I am not given with x bar. I am not given with your y bar, or else I am never given with the sigma x, sigma y, or else sigma x square, sigma y square. Nothing is given. So it is joint PDF. So I have to find each of these scenarios, each of these values, and then I have to compute corresponding byx, bxy, r, and you know the formula of regression equations, right? Perform. So to calculate your x bar, right? To calculate your expectation of x, it is nothing but minus infinity x into f of x. So f of x is the thing I have to find it, right? It's the marginal PDF of x. So we have to find the marginal PDF. This is actually as a continuous case problem. So we have to go with the marginal distribution is fx of x. So fx of x is equal to integral minus infinity to infinity fx comma y dy, and where we know fx of comma y is 1 by 3 x plus y dy. So just go for an integration limit because this is with respect to y, so it is 0 to 2. So 1 by 3 0 to 2 x plus y dy, and so by finding a marginal distribution, it is 1 by 3. Integrating this one with respect to x, with respect to y, you will get xy plus y square by 2, and the limit varies from 0 to 2. So substitute your limit so that you will get the marginal distribution of your x as 1 by 3 to x plus 2. So we'll simplify it, we'll be finally getting this. Similarly, we can find the marginal distribution of fy of y, which is varying with fx of x comma y dx. The range of your x is 0 to 1. So proceed with an integration, and we will get the value of your marginal distribution of your ys. Yes. So fy is 1 by 6 of 1 plus 2y. So is the range is 0, y less than or equal to 2. So once we found the marginal distribution of x and y, we will be computing the mean and mean of x and y and variance of x and y. So mean is expectation of x is equal to x into f of x dx. So it's a continuous case, so 0 to 1, and it is x 2 by 3 x plus y dx. So we'll finding here by the integration and applying a limit 0 to 1, we'll be computing your x bar as 5 by 9. Similarly, when you're just proceeding with your expectation of y, it is y 1 by 6 1 plus 2y dy. Integrate with respect to y and apply the limit 0 to 2. Simplify it, you will get the mean value of your y bar. Okay, so we have to find the standard deviation, right? So to go for the standard deviation, I have to find the variance first. So we know the formula for the variance of your x and y. So variance of your x is nothing but expectation of x square minus expectation of x the whole square. This is applicable for the same y. So I have to find expectation of x square. So the same logic, it is integral minus infinity infinity x square f of x, and the range of your x is 0 to 1. So x square 2 by 3 x plus 1 dx. So proceeding again with an integration, we will be getting the value of your expectation of x is 7 by 18. Similarly, on proceeding with expectation of y square, we'll get 16 by 9. And with these two, or not these two, these four, we'll be calculating here expectation of, variance of your x and y, which is as I said, expectation of x square minus expectation of x the whole square. So substituting here, we'll may get it here expectation, that is sigma x square as this thing. So we want only the standard deviation. So sigma x is equal to root of 13 by 162. So sigma y is the same scenario, same procedure, we'll have to find it. So we'll get it is square root of 23 by 18. So now I found my mean, variance and standard deviation. So the question here is you have to find your correlation coefficient and also the regression equation. Right. So now let me go for finding the correlation coefficient. So to go for the correlation coefficient, there are two ways. One is finding your regression equation like x on coefficient x on y and y on x, or else we know the direct formula using expectation. So expectation of xy minus expectation of x into expectation of y. So to calculate your expectation of xy, we go for the double integration 0 to 1, 0 to 2, and xy fx of y. Go with an integration, apply the limit, then find the answers on computing or simplifying your integration, you'll get it as 2 by 3. So the covariance of the correlation coefficient, the covariance is given by expectation of xy minus expectation of x into expectation of y. So where R is given by covariance upon square root of variance of x into variance of y. Okay, so this is actually covariance, not correlation. It is covariance. So correlation is covariance upon sigma x, sigma y. This is sigma x and sigma y. So it is just substitute the value what we got it. So you get the covariance is minus 1 by 18. So substitute the formula of correlation coefficient R. So it is minus 1 upon 81 and sigma x, sigma y. So finally we'll get this as here R. So where here R is negative. Okay. So the first part of computing correlation coefficient is over. So next I have to find the regression lines. So we know the form for your regression lines, right? So that is x on y and y on x. So x on y, we know it is x minus x bar, sigma r into sigma y upon sigma x upon sigma y minus y bar. So substitute your x bar 5 by 9 and your r value is minus root of 2 by 299 and your sigma x, sigma y minus y bar. So make a simplification. So you'll get it as here x minus 5 by 9 is equal to minus 1 by 23 y minus 11 by 9. So again take this minus 5 by 9 to the other side and simplify it. On simplifying this one, you'll get it as minus y by 23 and it is 11 by 23 into 9 plus times and here also it's plus 5 by 9. So make a simplification. So you'll get it as here x is equal to, this is y, minus 1 by 23 by minus 14 by 20. Okay. So this will be the lines of regression. Similarly, y on x, y minus y bar, sigma y sigma x, x minus x bar. So substitute the values, you'll get this y is equal to minus 2x upon 13 minus 17 by 30. Okay. So this is the way we will be computing here regression equation lines. Okay. If joint PDF is given, how to proceed with the correlation coefficient and regression equation of lines. Hope you understand with this. Thank you.